Okay, I made like 3 videos yesterday trying to get the 3D printing to work. It was a nightmare. Took me 9 hours to print this block. Yeah, not so much. So the major problem I was having was the extrude rate. I was having some major slippage of the filament, and I tried to make my own little knurls in there. They call it hobbing, and it didn't work. What I ended up doing was just scraping the filament and ended up making a lot of filament dust. And so I hopped back on the forums, and everyone started talking about doing it with a tap, and I finally found out what that is. Take your bolt, stick it in a drill press, you spin it in a drill press or in a drill, you take a file, you file a little groove in there to start. There's a little filed groove. Then you put the 2 bearings on the bolt, the bearings that will eventually hold it. That whole thing gets clamped in a vise, so you basically have 2 bearings and a bolt that can spin. Then you put a tap in the drill and you hold it up against that groove you have made. And so again, these are in the bearings so it can spin, and as that tap spins, it just threads itself along the bolt, and it's like a worm gear. The bolt spins within its bearings as these threads go by, and it puts perfectly even little marks in your groove. And then beyond that, it took me 2 to get that right, and I'm probably gonna make a couple more, but I also had to work on the width of this, or the radius of this impression, and depth, and then but anyway, okay, so I got it. Yesterday I was printing at 90 millimeters a minute. Now I'm running at 800 millimeters a minute, slightly faster. So here's the extruder. I modified it. I put a washer on here, basically a plexiglass washer. It's bolted to the main gear. I tapped and threaded, or drilled and tapped the head of the bolt that accepts this guy to hold the gear on there. Added these little arms that push the bearing in, some springs, snug that up, and I burned out the resistor. So I switched to nichrome wire, and it seems to be just fine. It works great. I just looped it through the hole. 6 ohms, good to go. Little spring, little feeder stuff. Okay, now this is from, I should probably mention, this is actually a bridging test, not to try to bridge, but not to. None of these should be here. So I have some ooze problems. If I was doing this through RepRap software and through an Arduino, I would probably have, there's like a million settings for ooze and whatever else. So I could probably fix that via code, but I'll show you how I'm doing it. I'm using Mach 3. I'm printing from Mach 3 right now, and it's working. STL file from Thingiverse, or STL file from SketchUp. Then the STL file goes into Superscan, which is a processing app. Spits out G-code. Works fast, works great. So you have a text file, a G-code. Now you open up that text file, and you have to change anything that's a 101 into an M8, and anything that's a 103 into an M9. And what that does is, I'm sorry, I added some firmware as well to Mach 3. It was supposed to actually send serial data out to send extruder commands on and off, rate and temperature out to the Arduino. Couldn't get that to work. So for the record, I think I can just use off-the-shelf metric Mach 3 to do this without any firmware. But nevertheless, I am running firmware. What I'm also doing is I've got an Arduino, and I've got this little LCD screen, and this is a standalone controller for the hot end and the extruder motor. There's an easy driver for the extruder motor. There's a MOSFET back there. Now, I fried the MOSFET, so right this very second, what I'm actually doing is I'm watching the temperature of the extruder head, and I'm manually adjusting current and volt from my power supply to dial in the temperature I need. I just need to get a replacement MOSFET so I can control the extruder temperature. Basically, these are raw ADC readings, and I did all my calculations trying to figure out the correct temperature with the thermistor and the pull-up resistor I used, pull-down resistor actually. And then you can also see feed rate at 23%. I have my feed rate and my extruder temperature on pots, which just seems to be the simplest way to do it. Instead of modifying the G code to all these parameters and settings to dial it in just right, I just turn a friggin' knob and just adjust it, period. And I can do everything in real time. I can bump feed rate up and down at whenever. I can speed up the extruder to match. I can name that tune in one layer. I mean, literally, I got to the point now where I was able to dial in the extrude speed at and the feed rate exactly, one or the other, but get them exactly right within, one, an outline and 10 zigzags maybe. I could get it just right. So at this point, of course, the issue I've got now is this massive bridging going on. But what I think, I think it's extruder speed needs to be maybe just a tiny bit slower. Number two, I'm probably running a little hot. I can adjust that. I want to dial that just right. Number three, I think I'm going to add some code. So as soon as it's done extruding, as soon as it gets a stop turning command, I think I'm going to have it back up one step and just retract the filament like 2 clicks on the stepper, just enough to get a little pressure off of it, and see if I can get that to stop oozifying. So there you go. Here are some of my earlier attempts, but we are. Oh, heated bed looks like it's probably going to be a must, but we're getting there. Each print looks better and better and better. I still think I'm scooching out too much gunk, but yeah. So bottom line is I can officially mill. I can officially print, both of which just need to be just snugged up a little bit. Start getting some dust collection going in here for when I'm milling, and I'm getting really close to ordering steel. I'm going to. I think I've solidified my design, and I think pretty much I'm getting kind of comfortable with this machine and kind of running it through its paces and getting it to go. And I haven't run enough stuff to really say this yet, but I can say that things are becoming really routine. I can just use it now. Like I can just kind of like this particular print. This is the first print where I just zeroed out the head and hit go, and didn't touch anything. I really got it dialed in, and it's only going to get better. So yeah, I'm feeling more and more comfortable about starting the version 2 machine. Oh, sorry, one more. I clamped a diagonal on here tonight, and it's not even a full diagonal, but I clamped a diagonal on here, and then I put some guys going across, and I threw that slab of granite, this is sawdust, threw that slab of granite on the stand. That granite's probably 80 pounds, and then ran 2 diagonals for the gantry moving back and forth to shake. And that helped tremendously. It's going to be 1,000 times better when that's even more diagonal and welded, and when the gantry's not moving, when it's just the table. But that kind of proves it to me that I can use this stand. It's going to be hefty enough after I add a little bit more, some more diagonals. So that's super awesome. I'm going to get by with not a huge steel order, which I think is pretty cool. So to reiterate for tonight, because I feel if I go any longer, I'm going to ramble. I can 3D print on a CNC machine, and I can do it through Mach 3, through an Arduino, and extremely limited code in the Arduino. It's not even PID. It's if it goes over the temperature, turn it off. It goes under the temperature, turn it on, and check it once a second. That's it. It's like, yeah. Oh, and don't check the temperature if you're extruding. It only checks it in between extrusions, so the stepper timing doesn't get screwed up, which I think I'm going to have to modify, because if it's a major extrusion, it gets cold. And so I'm actually, believe it or not, thinking of doing this whole standalone controller for the extruder head, believe it or not, with a propeller. 8 cogs are going to be awesome, because then I can run a cog each for the PID for the heat bed, the PID for the hot end, and then another cog for the extruder itself. And God, that would be incredible. And then doing it through Mach 3 is equally awesome. It works so super well. It's one conversion step, one find and replace within a text document, which is like a piece of cake, and then you zink it into Mach 3 and zero it and go, and that's it. And all I have to do is make myself a little table or throw it on an EEPROM in the Arduino to remember all my numbers. And so when I fire up the machine, I just turn a little dial and say, I'm printing ABS today, and go. Or, you know, this is my feed rate, and then I get a little message on the screen, hey, your extruder is hot enough, you know, it's ready to go, etc., etc. And you hit go, and Bob's your uncle. So, bada boom, bada bing. I'm going to make more knurled wheels. I'm going to make another extruder to just tidy up this. This is all ugly with this MacGyver setup. So that'll be all sexy and pretty and cool. Ordering steel soon. For that, I can officially print, or I can officially cut, I can officially mill, I can officially print. Next thing is, oh, did I show you this too? Sorry, God, so much has happened. Did I show you that yet? I made this router clamp. It's just so much nicer than that big bulky where I actually had to use the base of the router. Okay, good golly, Miss Molly. I think, Jesus, are we done? Are we done? 13 minutes? I think we've got to be done. Okay. 3D printing off a CNC machine through Mach 3. It can be done.